Okay, so I'm going to show you the game I made in a week called Over Yonder, and I made this in Godot. So the main objective is to get through the gate before it closes. The controls are pretty standard. So movement is WASD or left stick, camera is mouse or right stick, attack is left click or right trigger, jump is space or A or X on controllers, menu is escape, and restart is hold the respawn button for 3 seconds. And what that means is like every time you hit one of these gold switches, your spawn point gets updated. And so if you ever want to basically restart the game, come all the way back to this one, you have to hold the respawn button for 3 seconds. So let's just demo this. I'm going to show you what happens when you die, death animation, and then you just press the respawn button. And here I'll show you what happens if you don't make it in time. You'll get smashed by the gate. Okay, so this is the second level. It's a jumping puzzle, basically. I'll show you what happens if you don't jump properly. Now you can go right or left up here. If you go left, there's a way to do that. And it's basically don't jump. If you don't jump and you just fall down on it, then you won't die. Also, let me just turn up the volume. I'm not sure how it's going to come through in the video. And the hitbox is actually the... Oh, shit. The hitbox is actually the mesh of the sword itself. So it's an area, and if it enters the character's hitbox, then that's how the hit is registered. Ooh, that was a close one. All right, so this next one, I introduce a new type of character. It's the hunter. I just want you to notice something cool. I think the smoke coming out of the gun barrel is pretty tight. That's the GPU particle effect that Godot offers. You can have the guy shoot his own guy. Oh, I gotta restart it. I was showing off the gun smoke, ran out of time. Oh, I guess I'm not that good. Come on. You see the gate smoke effect to emphasize that this is a big gate closing hard. Okay, this is the last level. You can either go left or right. I'm gonna go right. And that's the game, and that's Over Yonder. So let me exit out of this. Put the volume back. Oh yeah, you can show FPS. Not that. Doesn't really matter. This game isn't that demanding. So what did I learn? So maybe I'll start by explaining one of the scripts that's kind of fundamental to the game. It's the terrain cube. It's a script and it's a shader. So a terrain cube in Over Yonder is all the terrains you see on the ground. So okay, so like this whole ground is one terrain cube. So I took a cube primitive and I basically add roughness to it using noise to give it the rough texture that like a grass or a dirt would have. And then something like the brick walls here, it would just be, this is just a cube. So let's go to the script and let me just see. Oh, before I go there. So on the right-hand side, you can see I've basically set up tooling that, well, I'm the game programmer as well as the, I guess you say, game designer. So a designer might use these tools to kind of lay out a level where, you know, if I change this size right here to 20, then it changes the size of the ground. And then I can say it has roughness. That's the roughness for the, you know, grass dirt effect. I do have a ramp function in here. However, the problem with this is, so for some reason in Godot, when there's the two, you have an edge. Let's see if I can demonstrate this. Basically, like if you have two edges next to each other, two collision shape edges, for some reason the character would like glitch or jitter or teleport whenever I'd go walk over an edge. And I think that has something to do with floating point precision, because I'm generating these collision shapes programmatically. And so I think that has something to do with it. So I basically couldn't use any ramps, unfortunately. Online, I tried compiling Godot to run in 64-bit float precision. However, then the whole game kind of got messed up. I also read a suggestion to make the collision shapes smaller, like break them up. However, I tried that and that also didn't work for basically shapes that are kind of jagged and rough like this. So that was like kind of one limitation with the ramps that would have been nice to have. Edges here. So as you can see, right before the terrain ends, there's a little edge. So you can use this to like generate longer, big edges. And you know, you could also modify this to kind of add some noise to how the edge is laid out, so it's not just straight. Is mountain is another part of the terrain cube script that basically generates these mountains. So it just modifies the top layer of the cube and just gives it a crazy height. slopes is part of mountain, so that's this sloping effect you'll get. If I didn't add any slope to this, it would look like this flat part of the terrain cube. Grass meshes, so that's all the little grass you see, so that's programmatically placed. So basically, so let's go ahead and dive into the code for a second. Terrain cube, okay. So basically what I do is you're using the mesh data tool to manipulate each vertex. And then what I do is I use the color attribute to determine what kind of surface it is. So is it rock? Is it dirt? Is it grass? And I basically, so for example, for the edges, let's see if I can find the edges here. I think the edges is this one. So basically for edges, it doesn't matter. So for edges, if the vertex is outside of the edge, then I set it to, it's the red color point here that we'll use in the shader to say, okay, this is a rock surface, so give it the rock texture. And then for the grass, I actually use the normal of the vertex. So I just copy and pasted this section right here from Godot's documentation. This is just a way to recalculate normals after you've manipulated the vertex data. And then I loop through the vertex data again, and basically here I say if the normal's y value is less than 0.9, make the red color 1, which means it's a mountain. This one is this one is dirt. I don't even remember. It's dirt and grass. So as you can see, it's hard for me to even, this was done in a week. I've kind of scrapped it together. There's probably a lot of organization and refactoring I could do to make this make more sense as opposed to just executing it in one big thing. But so I'm basically, using the y value of the normals to do things like determine the textures and place grass meshes. Actually, here's the grass mesh part. So what I do is I save. So whenever I'm generating these, either the terrain mesh or even the grass positions, I save it locally under, let's see, here we go, terrain cube meshes level. So you'll see a bunch of meshes. Let's see, where's the grass? There should be a spot for grass points as well. I save it as an array. I don't know where it is right now, but so I save it locally. I tried doing this where you would just generate all the meshes at runtime every time, but that did take quite some time. And because those meshes are static and they'll always be the same no matter what position they're in, I just save it locally, and then during runtime, you have the assets and you just load them. Another small detail, so all the noise, I use world coordinates so that when these two terrain cubes are next to each other, like they line up, that they have the same kind of noise, so they don't look like they don't match. Let's see, and then we can go to the shader. Terrain cube shader. So let's see. Yeah, so basically I have two kind of colors. There's the surface color, which is the grass and the dirt, and then there's the base color, which is the rock. First, I'm mixing the surface color. So if this was even a surface, is it grass or is it a dirt? And then I'm mixing that surface value with the base, the rock. So now let's say this is a grass, but now is it a grass or is it a rock? So you use the mix function to do that. And remember earlier I had stored the whether or not it's a grass or rock in the red color value. And so that you can see I'm referencing it here, color.r. So that ends up becoming the value between 0 and 1 of how much of this is a rock, how much of this is grass. Yeah, it's kind of the same for the normal map as well. I have two tri-planar normal textures here. So by the way, these functions also are auto-generated if you like create a standard material. I don't know what that sound effect was. If you generate a standard material and then you on the drop-down menu you say convert to shader material, like it'll auto-populate a shader and then you can kind of use their functions, like copy and paste them basically. So that's how I even got these functions. I had to have two functions here because for some reason when I wanted to calculate the same values for the normal textures, it was showing me an error. So I just made a second function and that solved that problem. So yeah, that's the terrain cube and script and shader, and I used it for all the terrain you see here, except for that ramp. This ramp is just a custom one-off since I had that issue I was talking about earlier. Okay, let's see. Mixamo and character animation combiner. So for the animations, I went to Mixamo. Some of you may be familiar with this, but they have a bunch of cool animations. You just download them. And you can upload characters here. So that's where I uploaded my characters to get the animations. And then I use this other tool called Character Animation Combiner to more easily put a bunch of animations together. Maybe we can peek at the animation tree here. So like this is the animation tree. You've got a big transition, which is how you navigate between all the animations, and then the one shot is like your attack, so left-handed swing. And the cool thing is the one shot has filters. So if you enable filtering, you can apply the animation to only some select bones. And that's how you're able to have it where I'm running and I can swing at the same time without stopping the running part of the legs. Because if I didn't have that, his swing animation would be like his feet would go stationary, but he'd still be moving. So either I'd have to have you not move while you swing, or it would just look weird where you're running and the legs are stationary as you swing. So yeah, that's the animation tree. Particles. Particles is pretty cool. So the easiest particle was the blood. So this is a GPU Particles 3D. And basically there's a bunch of settings here that you can play with. So you can see explosiveness, I've turned up all the way. Randomness. Oh, an important thing on particles is this visibility. I think it's area box or something. Basically, you want to make this really big because if it's too small, what will happen is you would turn away from, let's say, this an effect that's happening, and it would basically stop the particles, and then when you turn back, it would resume the same particle even though time has passed, and that particle effect should be done. But to fix that, you make the visibility AABB really big. Dust was pretty cool. So with this, when I first made the smoke, it looked very cartoonish because why did it look cartoonish? Oh, the alpha. So I was using alpha scissors on the material. Let's see if I can show you that. Where am I going? Particles, dust. So I was using alpha scissor, and it just looked, something didn't look right. And this is supposed to be smoke or dust. But when I changed it to alpha, then that was better. You want to use as albedo for the vertex color if you're manipulating the color. So you can see that this dust is like the transparency is becoming less opaque, but that can only work if you're using the vertex color as albedo. Okay, let's see. The gunfire is pretty cool. So this could have been even cooler if I varied the textures here. This is just the same texture. But here, let's just do this. Okay, so there's two parts to this. There's this part in the front you can see here. This you can see from the sides. So it's just two plane meshes. And you have to enable particle billboard mode or something so that you can see it from all angles. So it's just a vertical plane and a horizontal plane. And then the problem was if you're looking at it head on, you can't see this part of it. So that's why I added that thing in the back. Gunsmoke was cool. So this one, it's like you basically gravity, you turn it upside down. So gravity is going up and by a small amount. So here I have it set at 1. If I set it at the default 9.8, it would like go too fast. And the way it's moving like all over the place is the turbulence setting. So you just enable turbulence and you can just kind of play around with this. And that's how you get it to like kind of look like smoke. I also have the scale here. So with the scale, similar to what I was saying earlier with changing the alpha of the color, you need to set like keep scale in the material. Let me double check what that is. This is Gunsmoke. Okay, here under billboard, particle billboard, and then keep scale. So that's how you get the scale ramp to work. And let me just show you that. So like here's the color ramp. You set a color and then you just have it. Well, this is a gradient, but that's how the color ramp works. And then the size one is an actual curve. So here goes from 1 scale to 0. Okay. And let's see, what's the next thing here? Oh, very repetitive sounds. So footsteps, the way the footsteps work is similar to how you see these swings on the left-hand side. So I just have a collection of footsteps or swings that are different. You could also have the same sound and just change the pitch. That'll work too, but it's nice if you have completely different sounds. That helps, because you're going to be hearing the swings and the footsteps very frequently. So you want to change it, one, so it sounds kind of realistic, and two, so it doesn't get annoying. So why don't I continue developing over Yonder? So I've made the 4th level, and I don't know, I kind of ran out of ideas, I guess. Basically, you got the dwarfs with the axes, that's the melee unit. You got dwarfs with the guns, that's the range unit. You had the jumping puzzle, the element of height and falling. And then this was kind of a combination of just the range and the melee. But I don't know, I couldn't think of any better ways to, combine those same elements to make something new. And because this is a solo dev effort, I want the reusability of the assets to be higher. That's also why I didn't have a boss. I mean, it could have been cool just for a learning experience, but because the boss is a one-time use thing, usually when you develop a boss, you're only going to fight him one time. I don't know, I just felt like it was a lot of work for something that's only going to be used once. Maybe I'm just too lazy, I don't know. But that was kind of my take on it. And, even this, you can beat this in 5 minutes. And it took me a week to do, but, mentally, it's quite, taxing. So, I've been thinking about maybe, I've always thought about what about a multiplayer game or something like Battlefield 2. And the cool thing about games like that and Counter-Strike is the models, the reusability is pretty high. In Counter-Strike, you have terrorists, counter-terrorists. Everyone is going to have the same animations, the same kind of guns, I guess. So maybe something like that where the reusability, the reusability is just higher. Okay, and last point here, GitHub LFS. So I use Git and GitHub for versioning, but I didn't know about this LFS, which is GitHub large file storage. So I'm not committing my assets to the GitHub repo, but GitHub has a large file storage thing where you can commit it, large files, and they will just store a pointer to the file, and then they store the file somewhere else, I guess. I think it costs $5 a month. I'm not sure, but if I work on something else that's game related, I'd probably use this. Okay, that's it. So I'll release this on my itch.io page. I'll provide a link in the description box of this video. Thought it should be cool to share my learning experience here, and thanks for watching.